Annuities. So for this video, our objective, we want to determine the value of an annuity. Well, first off, what is an annuity? An annuity is a sequence of equal payments or deposits made at equal time intervals. So regular payments of the same amount made at regular intervals, generally monthly is what we're talking about here. And they can either be deposits into an account or they can be payments from an account. We're going to focus on making deposits into an account to achieve a future goal. Examples of this type of annuity: an individual retirement account, you're putting money away for eventual retirement, or another type of retirement account is called a 401k, often provided by companies you work for. And let's define, when someone says what is the value of an annuity, they're talking about what is the sum of all the deposits plus all the interest that you were paid. Okay? So the future value, or the whole annuity, is all of the deposits plus all of the interest. Well, no reason to get ourselves wrapped up into how the formula came about, because it's a long one and a big one. We're just going to make use of it. So the value of the annuity at the end of T years is equal to this rather hefty fraction. In the numerator, we have the amount of every deposit, so amount of each equal size deposit, times, we have in parentheses here the sum of 1 plus the interest rate as a decimal divided by the number of times it's compounded. That sum raised to the number of times compounded per year times the number of years, and then subtract from that the number 1. In the denominator, we repeat this little section. We're going to divide this whole numerator by the annual interest rate as a decimal divided by the number of times compounded per year. All right, so we're going to make use of the formula, and I'm going to show you how to do that with Desmos. Desmos makes that formula kind of easy to input. Example number 1, at age 30, to save for retirement, you decide to deposit $100 each month into an individual retirement account, and it pays 9.5% compounded monthly. One of the things you'll notice here is that the equal time intervals will equal the compounding period to keep this simpler. So your equal size payment will be $100, and you will make those each month, and you'll do that for, letter A, you can do that for 35 years. How much will you have? In other words, what will be the value of your annuity in your IRA when you retire at age 65? Okay, so we're going to go 65 minus 30. We're talking 35 years putting in $100 a month every month, compounded monthly. Okay, let's take a look at this formula. The value of the annuity at the end of 35 years, our amount of equal size deposit is going to be $100. So that's here for, we'll put it in there, is $100, and then parenthesis, 1 plus the rate is 9.5% as a decimal, that's 0.095. We're paying monthly. N is the number of times compounded per year, so we're compounding 12 times per year. Close that second parenthesis, raise it to the number of times compounded times the number of years, T is in years, and we're doing this from 30 to 65, so we're doing this for 35 years. Subtract 1, and then close that initial parenthesis. I'm going to divide all of that mess. Divide that by 0.095, the rate as a decimal, divided by the number of times compounded per year. Okay, as I said, Desmos makes this fairly simple. We're going to be looking in that upper left corner, so I'll tap in there. This whole thing is a fraction, so I'll first press the division key to get a fraction. Desmos does not have brackets, so we'll use parenthesis followed by parenthesis. So 100, parenthesis, parenthesis. Notice that Desmos kind of makes one of them larger than the other. 1 plus, well, the next thing is a fraction, so I'll press the division key. 0.095, which is 9.5% as a decimal, over 12. And then I will come to the right and I'll close that parenthesis. And then I'll use my exponent and I'm going to say 12. You can press times here. Whoops, you can't do that. I forgot about that. Let's put in 12 parenthesis. Whoops, I seem to have lost. Okay, there we go. 12 times. Got to make sure you keep it in the exponent. 12 times 35. So that's in the exponent. I'll come down and I'll put a -1. And then I'll close the parentheses. Again, notice that Desmos has a little larger parentheses as the outer parentheses and a little smaller parentheses as the inner parentheses. The denominator is a fraction, so I'll put in a fraction. 0.095. Whoops, I forgot the point. 0.095, there we go. Over 12, and there you have it. Desmos gives us our answer right away. $333,946, and we'll round this to the penny. How about 30 cents? Huge amount of money. So let's move that off the side. And we are, let's see, let's get my paper straightened out here. Right there. Okay, we're going to have, as we just saw, $333,946.30. A whopping amount. That's the power of compounding for you, which we saw in some previous videos on compound interest. Okay, so this is you keep putting in on a consistent basis. It's being compounded as you go, and it continues to grow and then grow faster and then grow faster and then grow faster. It's rather fascinating. Okay, letter B. At age 65, wait till you see this. How much will you have contributed to the annuity and how much was earned in interest? Okay, so first off, what is your contribution? Well, you put in $100 every month, and there are 12 months in a year, so we'll times that by 12 months in a year, and we did that for 35 years. Yes, 35 years. And I'm going to do this again because I want to make sure my number is correct. 100 times 12 times 35. I was correct. You contributed $42,000 over those 35 years. Your contribution is not that much compared to what you ended up with, which is, over $300,000. Okay, how much was earned in interest? Well, let's go back to here. Okay, the value of the annuity is the sum of all deposits plus all interest paid or earned. So let's go back down to here. Okay, the value, so the annuity value. Whoops, I got to spell value with a U. Is equal to the total contribution, the sum of all the deposits plus the interest you earned. Well, we know the value. The value is $333,946.30. $333,946.30. $946.30. And we know the total contribution. We contributed $42,000. So what's left must be the interest, okay, because the value is contributions plus interest. Let's subtract $42,000 from both sides, and it turns out the amount of interest that you earned on this, $291,946.30. My goodness, again, there's the power of money and time. You only contributed $42,000 over those 35 years, but because of the power of compounding and the power of time, the amount of interest you earned on those contributions was just below $300,000. So a lot of money was earned by just letting your money go to work for you. In the next video, we're going to do the opposite. We're going to determine how much you need to deposit every month to reach a goal.